Hello everyone, and welcome back to the Fluctus Channel. The B-2 Spirit was created to do something few aircraft could attempt: cross-defended airspace, remain difficult to detect, and deliver heavy weapons against important enemy targets on the ground. Its broad flying wing shape has no conventional tail, no exposed engine pods, and few sharp features that would strongly reflect radar energy. Instead, the aircraft blends wing and body into one smooth form, reducing its radar signature while also giving it enormous internal volume for fuel and weapons. The bomber first flew on July 17, 1989, from Palmdale, California. More than 3 decades later, it remains one of the most recognizable aircraft in the U.S. inventory. Its wingspan is about 172 feet, yet only 2 pilots operate it. The aircraft can fly more than 6,000 nautical miles without refueling, and much farther when supported by aerial tankers, allowing missions to begin in the continental United States and reach targets across the world. Before a strike, the mission begins inside the weapons bay. Munitions, airmen inspect, bomb racks, guidance kits, electrical connectors, suspension points, and loading equipment. During Global Strike Challenge 2021 at Whiteman Air Force Base, conventional weapons teams practiced loading the B-2 under timed conditions. Bombs are moved into position on specialized trailers, raised carefully into the bay, aligned with the rotary launcher or rack, and secured. Technicians then connect each weapon to the aircraft's electrical and release systems before another team verifies every step. The B-2 carries weapons internally because anything hanging beneath the wing would increase drag and make the bomber easier to detect. Depending on the mission, it can carry precision-guided bombs, penetrators, or other conventional and strategic weapons. The internal bays also protect the load during long flights and allow the aircraft to preserve its smooth stealth profile. Takeoff reveals why the flying wing design is so distinctive. 4 engines are buried deep inside the airframe, with carefully shaped inlets and exhaust paths. As power increases, the B-2 accelerates with no tail rising behind it and no separate fuselage hanging beneath the wing. Its control surfaces make constant computer-guided adjustments because a tailless aircraft would be difficult for a pilot to stabilize manually. Once airborne, the broad wing creates lift efficiently, and the bomber climbs with a dark, almost seamless silhouette. During a strike, crews follow a carefully prepared route built around fuel, weather, threat locations, tanker tracks, and weapon timing. Navigation systems guide the aircraft toward release points while the pilots monitor aircraft health and mission updates. As the bomber approaches the target area, sensors and computers help confirm position. Bomb bay doors open only for the shortest practical time. The selected weapons release, and the doors close again as the B-2 continues through or away from the defended zone. Some historical heavy airdrops help explain the destructive scale of large conventional weapons, even when the delivery aircraft is not the B-2. The BLU-82, nicknamed the Daisy Cutter, weighed about 15,000 pounds and was dropped from cargo aircraft for missions requiring an enormous blast effect. Loading such a weapon required rigging, inspection, restraint systems, and precise release procedures. The B-2 uses a different internal delivery method, but the principle is similar. Every strike depends on specialists who prepare the weapon long before the aircrew reaches the target. The result is not silent flight in the literal sense. The B-2 still produces engine noise. Its silence is operational. It is designed to arrive with less warning, release weapons from altitude, and leave before an enemy can build a complete response. The aircraft's real power comes from combining range, payload, low observability, precision, and two-person crew coordination into one strike platform. Every phase is rehearsed because a sortie can last many hours and may depend on several aerial refuelings.
And contact interface.
The pilots manage fatigue, communications, navigation, and changing orders while ground teams track the aircraft from command centers. After release, bomb damage assessment may come from other sensors, but the B-2 crew still has to fly the long route home. That combination of endurance and surprise allows one aircraft to threaten targets that might otherwise require a larger package of fighters, electronic warfare aircraft, and escorts operating together across hostile airspace. Long-range missions place unusual pressure on both crews and machines, so the B-2's support cycle continues even when its engines remain running. During training at RAF Fairford, crews practiced hot pit refueling, a technique that allows the bomber to receive fuel without completing a full shutdown. The aircraft enters a controlled area, teams position refueling equipment, and maintainers approach only after the engines and hazards are understood. A hot pit is choreographed. Wheel chocks are placed, communication is established, fuel connections are checked, and technicians watch for leaks or abnormalities. Loose equipment and vehicles must stay clear of intake and exhaust zones. The aim is to shorten turnaround time while preserving safety. The stop can also support a crew change. After hours in the air, one pilot team may hand the aircraft to another. The arriving crew brings mission material and personal equipment, while the departing pilots brief them on aircraft condition, fuel status, maintenance concerns, and changes to the plan. Access to the cockpit is controlled, and the exchange happens without treating the bomber like a parked aircraft. Once fuel, crew, and checks are complete, the B-2 can return to the runway and continue the mission cycle. Maintenance is even more demanding because stealth depends on details that would be mostly cosmetic on another aircraft. Technicians inspect engines, hydraulics, landing gear, avionics, flight controls, tires, electrical systems, and the airframe. They also examine seams, panels, fasteners, edges, and radar-absorbing materials. A damaged surface or poorly aligned access panel can affect low observability, so repairs must restore both structural function and the intended outer shape. During bomber task force operations in Europe, maintainers work from deployed bases with tools, parts, diagnostic equipment, and technical data brought from home stations. Engine work may require opening large panels above the buried power plants. Flight control checks move the elevons through measured positions, while crews watch for the correct response. The aircraft is then serviced, cleaned, inspected again, and prepared for another sortie. This explains why stealth bombers are supported by far more people than the 2 pilots visible in the cockpit. Weapons, troops, fuel specialists, crew chiefs, low observable technicians, avionics experts, engine maintainers, and operations planners all contribute. The B-2 may cross the sky alone, but on the ground it depends on a large, disciplined team that keeps every system ready. Stealth aviation did not begin with the B-2. Modern stealth aircraft proved that shaping and materials could reduce radar detection, but they also revealed how difficult unconventional designs were to control. The F-117 Nighthawk used flat, faceted surfaces that redirected radar energy away from the transmitter. Its shape was aerodynamically unstable. Digital flight control computers made it practical. Sensors measured the aircraft's motion, and computers commanded constant corrections through its control surfaces. Automation handled adjustments needed to keep the aircraft stable. This fly-by-wire approach helped transform a shape designed for radar reduction into an operational strike aircraft. The F-117 entered service during the Cold War and later became famous for precision attacks during Operation Desert Storm. Its success showed that a small number of low-observable aircraft could reach heavily defended targets with less support than conventional strike packages. However, its faceted design reflected the computing limits of its development era. The B-2 applied the same goal through a smoother flying wing. Advances in computer modeling allowed engineers to calculate curved surfaces, edge alignment, engine placement, and control behavior more precisely. Radar-absorbing materials and specialized coatings helped manage energy that reached the airframe, while buried engines reduced exposed components and infrared clues. Stealth coating is not ordinary paint. It forms part of a larger system that includes shape, seams, inlets, exhaust treatment, antennas, and mission planning. Maintaining it requires controlled preparation, approved materials, curing time, and careful inspection. The B-2's first flight in 1989 marked the arrival of a bomber built around that complete approach. Its history connects 2 generations. The F-117 proved that stealth strike was possible. The B-2 added intercontinental range, heavier payload, and a smoother design controlled by advanced computers. Together, they changed how air forces approached defended airspace, making information, geometry, software, and maintenance as important as speed. The B-2 was designed for decades of service, but its successor is already taking shape. On the 2nd of December 2022, the U.S. Air Force publicly unveiled the B-21 Raider at Northrop Grumman's facility in Palmdale, California. The ceremony revealed another flying wing bomber visually linked to the Spirit. The B-21 is intended to become the backbone of the future bomber force. It is being developed to conduct conventional and nuclear missions, penetrate advanced defenses, and operate as part of a connected family of systems. Like the B-2, it places engines, weapons, and many sensors inside a low observable airframe. The emphasis is on survivability, adaptability, maintainability, and the ability to receive upgrades throughout its service life. Open system architecture is central to that idea. Instead of locking the aircraft into one generation of hardware and software, the program is designed to accept new weapons, sensors, communications equipment, and electronic capabilities as threats change. The Raider will not instantly replace every older bomber. The transition requires testing, production, training, new facilities, maintenance procedures, and operational experience. Until enough B-21s enter service, the B-2 continues to provide long-range penetrating strike capability, and crews continue refining the tactics that the next generation will inherit. The connection between them is clear. The B-2 demonstrated that a flying wing could cross continents, evade detection, and place precision weapons on distant targets. The B-21 aims to make that capability easier to sustain, update, and deploy in larger numbers. From weapons loading and silent approach to hot pit refueling and stealth repair, every B-2 lesson feeds the future bomber force and shapes how future crews will operate in combat. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.